Good morning, everyone. My name is Jean-Pierre Laisné, and I'm working on CompatibleOne since years now, and I will try to explain how we work together and what we did achieve. So, first of all, thank you to be there. Second, thanks to these guys to be there too, because we would have less results without the collaboration between both organizations and ourselves. In fact, everything started years ago in 2009 when we, in OW2, launched OW2 open source cloudware initiative, and we asked ourselves, is cloud computing, let's say, an interesting topic for open source? Is there any chance that due to the cloud, open source may disappear? Okay, or kind of dilution of open source because on the cloud you don't need to show the code. So it was a question years ago, and I think it was a good question because in fact it turns out that we were right. Open source and cloud are two different animals, and we'll discuss that right now. In fact, what we discovered at this time is that there was a key player named Amazon, okay, starting in 2006, and the idea for Amazon was quite simple. I will provide the cars, I will provide the roads, I will provide the gas station and the gas of the cloud. Everything is open, but it has to be Amazon's. And it worked quite well because in 2013, on the figures we got, we can collect from Amazon, AWS represented something like $4 billion revenue for Amazon, which is pretty nice. It's a good start, and can be even bigger according to the growth of that. With these figures, Amazon is the first, #1 in the world on market. Now, other players had exactly the same ideas. Microsoft Azure, for instance, present exactly the same model. You can use Microsoft Cloud if you use Microsoft cars to go on Microsoft roads with Microsoft gas station and gas. Same thing for Google. Google launching Compute Engine, exactly the same, no standard, but and as surprising as it can be, it is also the case of OpenStack. OpenStack is an open source project, but they also provide roads, cars, and gas. In fact, with all that we can ask ourselves, is that so open? You have so multiple roads, generally not crossing. So how can you work on interoperability, on things like that with that? How open is it? And this is what we started to work on with CompatibleOne in 2011, sorry. So the goal was to say how to make all that interoperable. So we thought that thanks to open standards implemented by players, we could be able to have some interoperability. But Google, Amazon, Microsoft, any of them, even OpenStack, would not implement an open standard. Because in fact, what we discovered with cloud, it's not a question for them of standards, it's a question of being the de facto market standard, providing the API that enables them to, let's say, control, lock, or whatever you call it, the maximum market share as possible. So in fact, these are APIs by nature are open. Okay, you can use them. They expose services, they expose things like that. But each one has its own. And interoperability is not something which is natural in cloud. That's something that you have to build. You need to build the interoperability you want to deal with, and that's exactly what we've done with CompatibleOne. Now, to build this interoperability, the idea was to to say, okay, they won't use standards. They won't use open standards. They won't use CME. They won't use. But why don't we use a good standard to modelize what we are doing? And we took OCCI, Open Cloud Computing Interface, promoted by OCCI Working Group. And based on this, we created a model which enables not only to describe any kind of service and to discover any kind of infrastructure service, but also enrich it with other models such as platform, such as software, or anything as a service. This was the first step. It was to define the model that would enable to describe in a uniform way any type of service. Then the idea was to implement this model on a platform, okay, and that's what we did, based on OCCI. I recommend you to have a good look at OCCI. It proposes a very lightweight protocol to exchange on top of HTTP, and it's a model-oriented, object-oriented model that can be reused very easily. Now, this was something interesting, so we implemented that. With this model, we could be able to deploy anywhere, okay, because the platform itself is talking OCCI, and with the rest of the world is talking native language from EC2, from Nova or whatever. So we had a uniform way of talking to anyone, which was one part of the question. The other part is, okay, now we can provision any providers, but how do we choose them? So to choose them, in fact, on the infrastructure means that you have to be able to control what they deliver in terms of performances, in terms of availability and things like that. So we implemented monitoring tools, an agent that enables not only to deploy and post-configuration, but also to do real-time control on any workloads deployed on any provider. So it was a good way to see if this provider is better than that one, but on which criteria would we choose? And this is where also we discovered that what the providers are calling SLAs, which are mainly availabilities and 999, etc., is not what customers are naming SLAs. SLAs from a customer point of view is of course reliability, but it's also the way the security will be managed, or the fact that I want my workload to be deployed in France and not in UK or not in the States. Or I want my workload to be able to cost this amount of money and things like that. So we decided to manage the SLAs from two points of view. The point of view of the provider, what the provider can supply, and what wants the customer. And we do the matching, and the platform automatically does the matching with those criteria. So in that fact, what have we done? We have done a standard platform. This standard platform can provision and deploy any type of workload. Those workloads can be monitored, but also the deployment can be done according to criteria. I want to deploy on secured side, or I want to deploy on such territories, I can do it. This is what we got at the end of 2012. And when we discussed with the rest of the world, and we talked with people from NIST, we discovered that we have built what they call a cloud service broker, a technical cloud service broker, which provides intermediation between providers and consumers, aggregations of services, a kind of arbitrage to drive the workloads at the right place, etc., etc. And guess what? Gartner agreed on that when we discussed with Daryl Plummer, recognized that we were building a cloud, what they called a cloud service broker too. Now, what does that mean? That means that instead of consuming computing power in silos. Okay, so you put your workloads in Amazon, but there are lots of chances that you stay with Amazon, or you put it on soft layer, but you won't put the same on Amazon, etc. So in silo mode. With CompatibleOne, with a cloud service broker, you can intermediate and then take advantage of the offering. Okay, the offering now is not only Amazon, you also have soft layer, but you have new people such as Cloud Sigma, you have new people such as DigitalOcean and things like that, and maybe your application would be better in there than anywhere else. On top of that, we can do private or public cloud. For us, it's the same, the service, okay? The rules are exactly the same. And finally, we can deploy also on the application or Cloud Foundry, Beanstalk, or you name it. So hopefully we had some press early 2014, 2014, yes. And we decided to run a company and to spin off the project into a company called CloudOrbit. And CloudOrbit is now specialized on professionalizing the platform we have built with CompatibleOne and to enable people to take advantage of the diversity of the offering and to be able to build good business on top of that. Okay? So what is CloudOrbit architecture today? It's 3 layers. Of course, so you have all the providers. You have here what we call CloudOrbit brokerage engine, which is enabled by CompatibleOne, which is the result of CompatibleOne. On top of that, we have designed and written a full REST API to simplify the access to the platform, because if you can have access directly to this platform through OCCI interface, but you have to be aware of what OCCI is, and it can be complicated. So we proposed a full orbital API so you can build business applications on top of it. And this is what we are working these days on business application to enable the cloud brokerage. An example of that, a recent example of that is the collaboration we have with Cloud Screener. And Cloud Screener and CloudOrbit decided to launch together a cloud service store. So Cloud Screener is providing data about performances and about pricing of cloud providers. So altogether, we can choose the best solution for the application and deploy it automatically, control it in real time. And if something is missing, something is not, let's say, performant enough and things like that, we can change to another provider. So here you have the 2 layers, technical layers and business broker and business layer, and a user portal with a service catalog which enables users to say, okay, I want this package, I want this service for this price. And in 2 clicks, it's deployed and up and running. So here it is. That's the end of my presentation. And I hope you understand how we can evolve from an open source project to a real industry solution with lots of business opportunities. Thanks for your attention.